Welcome to your first virtual lesson for ninth grade advanced biology. Whenever you have a virtual assignment, the purpose of the virtual assignment is to be able to review a concept that you should have already learned previously in another grade or in another subject area, and you'll need to know to survive during this class, but we don't necessarily have time to teach it. So today's virtual lesson is all about reviewing measurements and the metric system. For our purposes, whenever we do labs or experiments, we want to be using the metric system. Metric system is internationally recognized, and it's a universal language. Everyone in the world uses the measurements for the metric system. Length is meters, mass is grams, volume is liter. We do not use things like feet, inches, pounds, gallons, or Fahrenheit when talking about temperature, because those are only part of the American system. They're not part of the international system. So if you do an experiment and everything that you weigh out is in pounds or ounces, and you send this experiment to someone in another country to try and validate your results, they wouldn't know how to repeat your experiment because they don't know what pounds or ounces are. They only use grams. So the metric system is very important. It is based on multiples of 10. Each step that you go up or down the ladder in the metric system is a multiple of 10. It uses prefixes which do indicate how many units of 10 are in that step. For example, kilo is 1,000. Centi is 100th. Think of century when you think of centi. We've got deca for 10, like a decade. So these words make sense. When you take your base measurement, meters, grams, liters, and you add the prefix, you can get the final unit for your measurement. So if we're measuring in hundreds of grams, you would have hectograms. If we're measuring in thousandths of liters, you would have milliliters. And all measurements need a unit. You cannot just put a number up there. You need to have a unit on it to know what the measurement is indicating or what it means. So if you follow along with your worksheet, we have this series of steps that does indicate the metric system. Our main step is where we keep our base units: gram for mass, meters for length, liters for volume. And notice they're abbreviated G, M, and L. If we go up the steps in increasing value, we have deca for 10 with a big D because it's a high value. It's a capital letter because there's also going to be a little d later on. Hecto is 100 and kilo is 1,000. You can go higher than 1,000 if you've bought a jump drive or a flash drive recently. You've heard giga. You may even have heard tetra. Giga and tetra are steps even higher than kilo. In our case, a lot of what we're going to be doing is going smaller, because we're going to be looking at a lot of things at a molecular level. Going down in tenths, we have deci for D. You always talk about having the decimal place. This is where little d comes in because it's a smaller unit. In the hundredths place, we have centi. Remember, century, hundredth, C. And then we have milli with a little m for thousandth place. There are 1,000 millimeters in a meter and 1,000 milliliters in a liter. We will go even smaller. We can talk about micros and nanos. Micro is the unit typically used to study bacteria. Notice its symbol is this Greek letter mu, and it's a multiple of 10 to the negative 6th. And then nano is 9. So we will see smaller ones. When we're doing metric conversions using this step system, there are 4 basic steps you can follow. First, you need to find the unit that you are starting with. In this example, we are starting with hectograms. So if I get my pen here and I find hectogram, hecto is right here. And I'm going to be going to centigrams. Find the unit you're converting to. Centi is down here. Count how many steps it'll take to go from start to end. So from my start of hecto to my end of centi, it's 1 step, 2 step, 3 steps, 4 steps. So I moved 4 steps to the right. So my number, 42 0.8, I take that decimal point and move it 4 steps to the right, just like I did on the ladder. 1, 2, 3, 4. And that puts my new decimal place here. I fill in all those empty spaces with zeros, and now my answer is 4, 2, 8, 1, 2, 3, 400. Oops, let's go back to that. It would be 428,000. Let's try this next one. We are going to be going from mm. So this m is meters, this m is milli. So we're going from millimeters to our base unit of just meters. I'm going 1, 2, 3 steps, and I moved to the left. So my decimal, if I can't see it, I assume it's at the end. Moving it 3 steps to the left, it goes 1, 2, 3. The new spot for my decimal is right in front of the 6. We have to start off with a 0 because it just makes the decimal look nicer, and you can clearly see that decimal. 0.612 meters. Let's try a couple more. So now we're going from little d, which is deciliters, to kiloliters. Again, I'm going to be starting at deci, moving up to kilo. So I go from start to finish, 1, 2, 3, 4 steps, and I moved to the left. Come down here, take it 4 steps to the left, 1, 2, 3, 4. That's my new decimal place. So I've got 0 point, I'm adding 2 zeros, 27, 2 kiloliters. Let's pick a different color here for this last one. I'm going to use magenta. I'm going from kilometers to decimeters. Remember, it's a little d, it's deci. So now I'm going 1, 2, 3, 4 steps to the right. And if I do that down here with my decimal place, I'm actually going to be, conveniently enough, adding 4 zeros. And that is the answer. So now you should have a worksheet of practice problems. You need to be turning it in by the due date listed on the calendar in the classroom. Good luck.